Leprechauns Felamach nabile Salikane Amhran Nafin. So for part A of this problem, assuming you read the problem in the description, we are given that the twice the distance is equal to r, but it's less than x. R is in Romeo, x is an X-ray. So we have to find S prime. Basically, we're looking for the image in terms of x as an X-ray and R as in Romeo. So yeah. Anyways, in order to do that, we need the Tin-Lens equation. So again, this is the Tin-Lens equation basically, but we can mathematically isolate one variable, and we are looking for S prime. So when you do that, you have to multiply both sides by S times S prime times F on both sides, and then you would get an equation similar to S prime of F plus S times F equals S prime of F times S, and then yeah. So we are looking for S prime. So let's put both S primes on the same side of the equal sign. So subtract both sides by S prime of F. So you get SF equals S prime times F, S minus S times F. So now you factor out the S prime, and then you get something SF equals S prime times S minus F, the quantity of S minus F, by the way. And now you divide both sides by the quantity of S minus F, and then you get SF equals S minus F. So that's your basic equation for that's a Tin-Lens equation in terms of S prime, but now we have to put it in terms of X and R. So we know that X is a little more than we know that X is more than twice the focal distance, so we can plug that in for S, since S is basically 2F plus X. So we let S equals 2F plus X, and then we plug in 2F plus X for S, and then there you go, 2F plus X. But multiply in the numerator, multiply both sides by F. So it'll be 2F squared plus S X times F. So now for the denominator we add like terms, so it's just F plus X. So we got X as one of the variables, but there's still F, and the answer does not use F at all. So now let's go up here, and now we have to let F as in Foxtrot equals R as in Romeo divided by 2, only because twice the focal. The reason why R divided by 2 is because R is equal. Unlike X, R is equal to twice the focal length. So yeah. Now that we plug in R for F, you get this conglomeration. So let's take out this conglomeration real quick. 2 and 4 cancel out to make 1/2. So it's just R squared divided by 2 plus XR over 2, and then that would just be R times quantity R plus X divided by 2, and then the denominator of this it simplifies to R times quantity 1 plus X divided by 2. So 2's cancel out. So it's just so S prime is just R times R plus X divided by R times 1 plus X. So the R's on the outside of the parentheses, they cancel out. So yeah, that's your answer for A. So R plus X divided by 1 plus X. So that's where the image would be. So in in terms of the equation, it would be over here where this yellow arrow is, and that's your answer for part A. So for part B, we have to determine if the image is going to be inverted or not. So as you can see, this is a convex mirror, so the image is not going to be inverted. Thank you for wasting my time. So for part C, we are looking for the magnification of this whole thing. So if you remember from the magnification equation, m is equal to y over y, and if we remember the proportionality of the two, y over y now is equal to s prime over s. So m can equal s prime over s. So but to make this easier, we'll make it s prime times 1 over s. So yeah. So for s prime, we calculated in part A as an alpha. So a s prime is equal to r plus x over 1 plus x, and then for part A, we also let s be a quantity. So s is equal to 1 over 2 times f plus x, and and this is your magnification. But then again, the the answer is only dependent on r and x. So we have to let f as in foxtrot equal to r as in Romeo over 2. So if we plug that in for f, the 2's cancel out, and then it's just r as in Romeo. So the r as in Romeo plus x as in X-ray cancel out, and then you would get And then you get the magnification equals 1 over 1 plus x, and there you go. That's your magnification.